All right, this is a digital SAT math test, subtopic geometry and trigonometry. It's an advanced level test, 10 questions. This is question number 1. Let's see what we've got. In the figure, the circle has center O, and it has a radius of 11. If the length of minor arc PQ is between 13 and 14, what is one possible integer value of x? Oof. Seems like a hard question. Well, all right. I mean, let's start by getting the circumference. The radius is 11. Give me a pen here. So the circumference would be 2 pi r, which is 22 pi. Okay. So that PQ arc is to, well, actually, let's say this another way. What is the value of x? All right, so x is to 360, which is the number of degrees in a circle. X is to 360 as some number between 13 and 14 is to 22 pi. So I don't know, let's start with 14 over 22 pi. We need a calculator for this. And I can't draw and scroll. All right, that's okay. I can get to the calculator. So we can cross multiply this. We've got, well, first we need to get 22 pi. 22 pi times x equals, so let's rewrite that. Well, let's cross multiply it. 22 pi times x equals 360 times 14. And then x will equal that. I didn't mean to cross out the x. The x is still there. X equals that over 22 pi. Now, it's not exactly 14. They gave us a number between 13 and 14. So let's try that. I'm going to write it down so I don't forget it. 360 times 14 over 22 pi. All right, bring on the calculator. Okay, exit the drawing. Move this over. And we're going to have 360. 360 times 14. I need to parenthesize that. 360 times 14 divided by 22 pi. All right, and we need some integer that is going to work for this. All right, so this answer is 72.9 something. What if the number was 13? It goes all the way down to 67. So it's some number between 67 and 72. I guess we could use 70, you know. That should work. So let's go back here and try putting in a number like 70. Oh, okay. A greenhouse has a cross-section in the shape of a symmetric trapezoid with bases of length 16 feet on the top, 22 feet on the bottom. The angles adjacent to the longer base have a measure of theta such that tangent theta equals 5. What is the height of the greenhouse in feet? Okay. All right, so let's do this. We can drop a line from here down to here, right? Now, oh, I scrolled that up too much. Okay, so but the top base is 16, all right? So if we drop a line here, we'll have a rectangle. It'll be 16 by 22. That's 6 feet left over. That means that over here, this segment is going to be 3. So the base, we could think of it as 3 plus 16 plus 3. All right. The tangent of these thetas is 5. Tangent is opposite over adjacent. Opposite over adjacent. So the tangent is going to be height over 3. And we're told that the tangent equals 5. All right. So if we cross multiply that, what we get is height equals 15. All right. Exit the drawing. Where can we put the answer? Oh man, my cursor is stuck. Oh, here we go. Oh, I see. Okay, let's try it now. No, it's still stuck. Let's try and scroll it up this way. Oh, that's going to work? All right. Well, in that case, let's go here and say that the height is 15. Okay. Given the angle measures in the figure, what is the value of R? Angle, okay, value of R. So let's do this first. These angles here, opposite angles. Oh, wait, I need a pen. Let's try that. Right here, that's also going to be 50. All right, now we've got a triangle. We know two of the angles, 75 and 50 is 125. Well, all right, so this angle right here is going to be, let's see, 75, 125, 180 minus 125. What is that? 55. So that's 55. Then with this angle, R, those are supplementary angles, meaning that they have to add up to 180. So R is going to be 125. Let's go ahead and put that in. 125. A top is formed by fusing two identical right circular cones by their bases as shown. The height of the top, H, height of the top, H, which is the distance between the two cone points, okay, is 6 centimeters. The diameter of the circular cone bases diameter is also 6 centimeters. What is the volume of the entire object in cubic centimeters? It looks like the way to do this is just to get the volume of one cone and then double it. Volume of a cone is, or the formula for volume of a cone would be, okay, I didn't mean to do that, but I mean, I guess we can live with it. Pi r squared times h over 3. All right, in this case, r, the diameter is 6, so r is 3. H is also 3. So what this is pi r squared. R squared is 9. We have 9 pi times height over 3. And the height is 3. So 3 over 3 is 1. So the volume of one of these cones is 9 pi. Let me double check this. Set the zoom back out. Okay, keep that in mind, 9 pi. Height of the top is 6, so really the height of one cone is 3. Diameter, so the radius is 3. What is the volume? 9 pi, so we got to double it, and it's going to be 18 pi. Choose one answer. All right, 18 pi. In the figure shown, an arc is subtended by a central angle measuring 3 pi over 5 radians. What fraction of the circumference is this arc? All right, 3 pi over 5. So let's start with that. I actually need a pen. All right, 3 pi over 5. 3 pi over 5. The arc of the whole circle is 2 pi, so we just need, the whole circumference. So we really just need to take a fraction, 3 pi over 5. What is the fraction of 3 pi over 5 as compared to 2 pi? We multiplied that out. What we would get is 3 pi over 5. No. 3 pi over 10 pi. 3 pi over 10 pi. Cancel the pi. We get 3 over 10. And I think that's what they want, is just a fraction here. So let's try that. It would be 3 over 10. Circle in the xy plane has the equation x squared plus y squared minus 14y minus 51 equals 0. What is the center of the circle? Circle in the xy plane has the equation x squared plus y squared minus 14y minus 51 equals 0. What is the center of the circle? Okay. Typical equation for a circle is x minus h squared plus y minus k squared equals r squared. R is the radius, h and k are the xy coordinates of the center. We don't care about the radius. There is no other x term, so the x, so really it would be like x minus 0. So the x coordinate of the center is 0. The y coordinate, to get the negative 14y, you're going to have y minus 7 squared. And so the y coordinate of the center is going to be 7. And that's it, 0, 7. A cylindrical soda can has a volume of 108 pi cubic centimeters and a height of 12 centimeters. What is the surface area of the soda can in square centimeters? All right, so to get the volume of the cylinder, we need the we have the total. We have the volume. We have the volume, and we have the height. So to get the area of the top and bottom, we can divide 108 pi by 12, which is 9. So the area of the top and bottom is, I need a pen again, 9 pi, and 9 pi for the top. It's also 9 pi for the bottom. So why don't we just call it 18 pi for the top and bottom? That's the surface area. All right. Now to get the surface area of the rest of the can, we need to multiply the height by the circumference. The circumference, all right, so the area of the top is 9 pi, it's pi r squared, so the radius is 3. The circumference is going to be 2 pi r, just 6 pi, 6 pi, all right, so then we have a height of 12 and a circumference of 6, and that comes out to 72 plus 18 for the top and bottom, and the total should be 90. All right, diameter of a circle graphed in the xy plane has endpoints at -23, 15, and 1, -55. Which of the following is an equation of the circle? All right, so the equation of a circle, in this kind of format is x minus h plus y minus k. I'm sorry, x minus h squared plus y minus k squared. H and k are the x and y coordinates of the center. These first two, x, plus 23, well, -23 is the x coordinate of an endpoint. It's on the circle. So, the first two just can't be right. It can't be an endpoint and the center. So that takes a lot of the fun out of it. Anyway, so the first two are wrong, and one of these second two are right. We don't have to do any of the computation here. Normally what you would do is just take the midpoint between -23 and 1, subtracted from x, take the midpoint of 15 and -55, subtracted from y, square both of them, and then square the radius. So we just have to get we have to get the radius. How do we do that? Well, we can do a distance formula here with these 2 points. That's the diameter. Let's go back over to this and say, now let me move the frame. All right, distance formula, x1 minus x2, which I forgot what they are, -23 minus 1. All right, -23 minus 1 squared plus, what's y1, y2, 15 plus 55, or 15 minus -55, but 15 plus 55 squared plus 15 plus 55 squared, oops, no, not like that, squared, it's 5476, but really we have to take the square root of that whole thing. So let's do that. Square root of 5476 is 74. That's the diameter. What we want in the equation is the radius squared. So the radius is half of 74, which is 36. 7. 37 squared is 1369. So that would be C. Circle with center O has a circumference of 20 pi. What is the area of the shaded region? Okay, so a circumference of 20 pi. So what is the radius? Circumference is 2 pi r, so the radius is 10. The area of the circle is pi r squared, so 100 pi. We've got a right angle there, so really all those angles have to be right angles. So that's a quarter of the area. The area is 100 pi. So that shaded region would be 25 pi. Here's a 60-degree angle. What is the value of the tangent of the angle shown? Let's see. To be honest, I can never remember tangents, but I remember that they are. I remember that it's sine over cosine. So the sine of a 60-degree angle is square root of 3 over 2. And the cosine of a 60-degree angle is 1/2. So you put square root of 3 over 2 over 1/2, which would be the same as multiplying it times 2. And the 2's would cancel. And so the tangent of 60 degrees would be 30. I'm sorry, square root of 3. Is that on here? Yes. All right, 10 for 10. Let's see. That's it. Hope you enjoyed it, learned something. Please feel free to like, subscribe, comment, and see you next time.